Hello all and welcome to the Basics.Academy channel. In this video, first we are going to learn about what prefix sum is, what are the pitfalls, edge cases that one must consider, and how to identify, given a problem statement, the patterns which tells us that the problem can be solved using prefix sum. So let us get started. For that, I'll go to Claude Code. I have already created a DSA pattern coach. Given a DSA topic, it will guide me through a step-by-step learning to understand the given DSA method, and it will also give me how can I identify the different patterns which will help me to come to the conclusion that certain problems belong to certain categories. Let us do that. So what I'll do, I get started and just paste in here prefix sum. Today I want to learn about prefix sum. And how does the DSA pattern coach knows what to do? Those instructions have been set inside the instruction field over here. If needed, if you want the instruction, please comment on the video and I send the instructions via the comment section itself. So let's get started.
Rate drops prefix sum as it is a very powerful set. What you already know. In your own words, what is a prefix sum and what kind of problem does it help solve? Take your time, don't worry about getting it perfect.
To be honest, we don't know about prefix sum. I may have solved problem of this kind earlier, but I don't know what exactly it is.
Honest answer, that's exactly what I needed to hear. Starting fresh is perfectly fine. Let me ask you one more quick question before we begin. Say I give you this array 3, 1, 4, 1, 5, and I ask what is the sum of elements from index 1 to index 3. How would you solve that? Walk me through your thinking. No code needed.
Okay, what is the sum of elements from index 1 to index 3? Index 1 has element 1, likewise index 2 has element 3 and index 2 has element 1. I will iterate starting from index 1, importing index 3, and on each iteration maintain some variable and keep on adding the element of index, and at last will return the sum element. Will return the sum, yes, the result.
Perfect, that's exactly right. You'd loop through the range, accumulate the sum, and return it. That works completely fine. Now, what if I asked you that same range sum question not once but 1,000,000 times on the same array? Would your approach still work well? What's the problem with it?
What if I asked you that same gained some question not once but 1,000,000 times on the same array? Would your approach still work well? It will still work well, but there will be a lot of decomputation, thereby affecting the and complexity, thereby in the domain of work.
Exactly. You've just identified the core problem that prefix sum exists to solve repeated recomputation. Each query costs O of n, so 1,000,000 queries costs O of n times 1,000,000. That's painful. Have you ever heard of the concept of precomputation or catching in algorithms where you do some work upfront so that future operations become much cheaper?
You are just identifying that prefix of exists to solve repeatedly computation. Have you ever heard of the concept of pre-computation on caching in algorithms, where you do some work upfront so that future operations become cheaper? Yes, I have heard of the concept, but cannot define those.
That's enough. Knowing the concept exists is all we need right now. One last question before we dive in. Given the array 3, 1, 4, 1, 5, if I told you the sum from index 0 to index 3 is already known, how would you use that to quickly find the sum from index 1 to index 3 without looping? Take a guess even if you're not sure.
The answer is simple. I will subtract element of 0 from sum.
Yes, that's the entire idea behind prefix sum in one sentence. You just invented it yourself.
Okay. So prefix sum.
Imagine you're a cashier writing down your running total of sales since the store opened. That running total column, that is the prefix sum array. If your manager asks for total sales from day 1 to day 3, you don't add anything. You just do total up to day 3 minus total up to day 0. That's 9 minus 3, which equals 6. One subtraction, done.
Okay.
The formula for any range sum from index L to R is prefix of R minus prefix of L minus 1. One subtraction, O of 1. No matter how large the array is. Before we go further, can you restate in your own words what the prefix sum array actually stores at each index?
Okay, mental model. Here's the core idea. Imagine you're on a cashier and every day you write down your running total of sales since the store opened. By the end of day for your ledger, it's like this: 2, 0, 1, 2, 3, 4. Okay, so before we go further, does that cashier analogy makes sense to you? Can you restate in your own words what the prefix sum array actually store? Here's the Cashier store analogy makes sense, and the prefix sum actually stores the sum of all the elements for a given index. Prefix sum actually stores the sum of all the elements, sum of all the elements for a given index, and it does not store sum of all the elements. It stores sum of all the elements up till that index.
Perfect. The prefix sum array stores the cumulative sum of all elements from index 0 up to and including that index. You've got it exactly right. Given prefix equals 3, 4, 8, 9, 14, what is the sum of the original array from index 2 to index 4? Use the formula prefix of r minus prefix of l minus 1. What do you get?
Now let me test whether the formula is truly clear in your head. Given this prefix sum array, prefix 3, 4, 8, 9, 40, it is the sum of the original array from index 2 to index 4. 0, 1, 2, and 2 we have 8, 8 at 4 we have 14. So prefix of r is equal to 14, and prefix of l is equal to 8. Thus prefix of l minus 1 is equal to 4 is prefix of r minus prefix of n minus 1 equals 14 minus 4, which is equal to 10.
Spot on. 14 minus 4 equals 10. And if you verify elements at index 2, 3, and 4 are 4, 1, and 5, which sum to exactly 10, the formula works. Now what happens when L is 0, meaning you want the sum starting from the very beginning of the array? What does the formula give you, and is there a problem?
Yes. In case of n equal to 0, it will fail with array index out of bound.
Exactly. When L is 0, prefix of L minus 1 becomes prefix of negative 1, which is out of bounds. That's a real bug. The elegant fix is to prepend a0 to the prefix array a Sentinel value. Now the formula becomes prefix of L plus 1 minus prefix of L equals 0 is completely safe because prefix of 0 is just 0. Quick check using the Sentinel version, prefix equals 0, 3, 4, 8, 9, 14. What is the sum from index 0 to index 2? Use the new formula, prefix of R plus 1 minus prefix of L.
r is equal to 2. So prefix of r plus 1 minus prefix of l, it becomes the prefix of r plus 1 is 2 plus 1, which is 3, minus prefix of n, which is 0. Prefix of 3 is 0, 2, 3, 9, minus prefix of 0 is 0. So the answer is 9.
Let's verify. Elements at index 0, 1, and 2 are 3, 1, and 4. What do those add up to?
Okay. The original array is t on okay, not required.
Prefix of 3 is actually 8, not 9. I had the Sentinel array slightly off earlier, my mistake. So the correct answer is 8 minus 0, which equals 8. Your formula application was perfect. Your formula was spot on, the error was mine. Always verify your answers against the raw array. Are you ready to move to phase 3, recognition training?
Let's do that afterwards, as I have some other commitments. So we'll do it afterwards. Thank you. I have a few questions. Given the original array, do we calculate the prefix sum array, or is it also given if we are going to add a Sentinel 0 and shift all the other elements? Won't that make the time complexity always be co-op in?
Great question. We always calculate the prefix sum array ourselves from the original array. It's never given to us, we build it up front as a one-time free processing step. Building the prefix array does cost Oven, you're right. But here's the key question. It delay costs Oven once, and then each of your million queries costs Ov 1. What is the total cost of answering a million queries?
It is big O of 1. If building the prefix array costs big O of m, but then each of your million queries costs big O of 1, what is the total cost of answering a million queries? Do we calculate the prefix array, or is it given?
Compare that to brute force without prefix sum. What would the total cost be for answering q queries on an array of size n?
Okay, so the total time complexity is big O of n plus q, where q is the number of queries, which comes down to big O of n. Compare that to the brute force approach without prefix sum. What would the total cost be there? The total cost there would be big O of n squared as, so with use an inner row that will always Start from hell and go up till earth.
Exactly. Eleven per query. Q queries total, so 11 times Q when Q is a million. That's devastating. Versus prefix sum, which is 11 plus Q. The pre-processing cost pays for itself immediately. The trade-off is simple: spend over upfront once, saved enormously on every repeated query after that. That's the whole point of precomputation. Are you ready to move to phase 3, where I teach you how to recognize when a problem is secretly asking for prefix sum, even when it doesn't say so explicitly?
Yes. Let's proceed.
There are 5 key signals that point to prefix sum. I've showed them on screen. Take a moment to read through them. Given an array and Q queries, each query gives two indices L and R. Return the sum between them. What pattern does this scream to you, and which signal tipped you off?
Range sum queries. Signal is range sum queries. Sum of elements from index I to R. Subarray sum equals K. Find subarray with sum equal to K. Multiple queries on same array. Answer Q queries on array. Running total or cumulative. Count of something up to index I. 2D grid sum queries. Sum of rectangle from R1 C1 to R2 C2. Okay, now let me test your recognition with a real problem statement. Hear this carefully. Given an array of integers and Q queries, each query gives you two indices L and R. Return the sum of elements between L and R for each query. What pattern does this scream to you, and which signal tipped you off? Prefix sum signal that tipped you off. Range sum queries.
Perfect. Read sum queries, that's the most direct signal. Now let me give you a trickier one. Given an array of integers, find the total number of subarrays whose sum equals K. No mention of ln or no mention of queries. Does this still use prefix sum, and if yes, why?
It uses prefix sum because the signal is subarrays whose sum equals K. Yes.
Correct on the signal. But I want to push you one level deeper here.
Okay.
For every index R, we ask, have we seen the value prefix of R minus K before? What data structure would you use to efficiently check whether a value has been seen before?
correct on the signal, but I want to push you one level deeper. Think about it this way. If the sum of subarray from index n to r equals k, and we know that subarray sum is equal to prefix of r minus prefix of n minus 1, then prefix of r minus prefix of n minus 1 is equal to k, which means prefix of n minus 1 is equal to prefix of r minus k. So for every index r, okay, we are asking, have we seen the value prefix of r minus k before? What data structure would you use to efficiently check, have I seen this value before? HashMap. HashMap data structure will be used to efficiently check, have I seen this value before? One question. Earlier we denied prefix of r minus prefix of l minus 1. As the generalized formula handling null equal to 0 as well. And for subarrays, again we are going prefix of r minus prefix of n minus 1. Why? Determines prefix takes only prefix of r plus 1 minus prefix of n.
Excellent catch, that's really sharp thinking. Both formulas are equivalent. They're just two different ways of indexing the same idea.
Here's the key insight.
Both conventions get the same answer. The Sentinel version shifts indices by 1 to avoid the L equals 0 edge case. Pick one convention and stay consistent. Mixing them is where bugs happen. In the subarray sum equals k problem, the hash map is initialized with 0 mapped to 1. That's the Sentinel, just expressed differently. It handles the case where the subarray starts from index 0.
Convention.
Does that resolve the confusion? Both are the same idea, just different ways of handling the same edge case.
Convention on no Sentinel prefix of I is equal to sum of elements from index 0 to array. Prefix of r minus prefix of r minus prefix of l minus 1 breaks when l equal to 0 with Sentinel 1 indexed. Prefix of I is equal to sum of elements from index 0 to I minus 1. But that is always same. Both give the same answer. The Sentinel model just shifts indicer by 1 over the L equal to 0 edge case. In the subarray sum equals k problem, most explanation use convention 1 without the Sentinel and handle L equal to 0 by initializing the hash map with 0 equal to 1. After meaning we have seen a prefix sum of 0 once before we started. That 0 equal to 1 initialization is the Sentinel, just expressed different. Okay, so to summarize, both formulas are the same idea. The Sentinel 0 in the array and the 0 1 in the hash map are solving the exact same edge case, just with different faults. Got it. Okay, so is it correct conclude that in case of solving a problem of prefix sum involving subarrays, we will use the formula prefix of r minus prefix of l minus 1.
Almost, but I want you to be more precise. The formula itself doesn't change based on whether subarrays are involved or not. The real rule is pick one convention and stay consistent. Mixing conventions mid-solution is where bugs silently creep in.
Okay.
The subarray sum equals k problem combines two patterns together. You already named both of them in this conversation. Can you recall what they are?
Back to where you correctly identified hash map for the subarray sum equals k problem. So this problem combines two patterns together. Can you name both? Two patterns, prefix sum with hash map.
Exactly. Prefix sum plus HashMap, that's one of the most common pattern combinations you'll see in interviews. Remember it well.
This is important signal, example phrasing, arrange sum coherent.
Given the binary array, find the maximum length subarray with equal number of zeros and ones. No mention of sum, no mention of k. Does prefix sum apply here, and if yes, what's the trick?
Let me give you one final recognition challenge before we move to pitfalls. Given a binary array, find the maximum length subarray with equal number of zeros and ones. Given a binary array, find the maximum length subarray with equal number of zeros and ones. Okay, no mention of sum, no mention of k. Does prefix sum apply here? And if yes, what's the trick? Finding the maximum length subarray with equal number of zeros and ones. Even though here k is not mentioned, k is dynamic and that is equal to the length of the subarray. Remember here k is not mentioned but k is dynamic and that is equal to the length of the subarray having equal number of zeros and ones. Having equal number of zeros and ones. Does prefix sum? If yes, what's the trick? Summation not find subarray is sum equal to k. Here the signal is find maximum length subarray equal number of zeros and ones which represents key. But let me let you follow the.
You're on the right track with the instinct, but the trick is even simpler. Let me give you a hint. What if you replaced every zero with -1? Then equal number of zeros and ones means equal number of -1s and ones. What would the sum of such a subarray be?
The sum of such subarray would be 0.
Exactly, the sum would be 0. And now what is k?
So the sum would be 0. K will be r minus ad. K.
Close, but k is not the length. Think about it this way. You just said the sum of the subarray would be 0. So what is k in the formula? Prefix of r minus prefix of l minus 1 equals k.
Prefix of r minus prefix of l minus 1. So prefix of r, that be 0. So if prefix of r is 1 and prefix of l minus 1 is also 1, that becomes 0. Key can be either 0 or if prefix of r is 1 and prefix of l minus 1 is 1, so that becomes 0. If prefix of r is minus 1 and prefix of n minus 1 is again 1, so that becomes minus 2. K can be either 0, minus 2, or say minus 1 minus plus minus 1. I think I'm drifting.
You already said the answer 2 messages ago. You said the sum of such a subarray would be 0. So k is simply 0.
So the entire transformation is replace every 0 with minus 1. Now the problem becomes.
The creative leap is this: a non-sum problem can be transformed into a sum problem by a simple value substitution. Replace zeros with -1s and k becomes 0. That's a powerful recognition skill. Ready to move to phase 4, pitfalls and gotchas. This is where most people lose marks in interviews.
Prior to that, let me go through phase 3 and want you to ask me questions about recognizing the properties. So the entire transformation is replace every 0 with minus 1. Now the problem becomes find the longest subarray with sum equal to 0. Okay, that's exactly the subarray sum equals key problem with k equal to 0. Solve it with prefix sum plus HashMap. The creative leap here is recognizing that a non-sum problem can be transformed into a sum problem by a simple line substitution.
Love that initiative? I'll give you probability statements one at a time. For each one, tell me, does it use prefix sum and which signal tipped you off? Here's the first one. Given an array of integers, find if there exists a subarray with sum equal to 0, prefix sum or not, and why.
Prefix sum because to find some array with sum equal to 0, that is k equal to 0.
Correct. K equals 0 subarray sum signal prefix sum applies. Next one. Given an array of integers, find the index where the sum of all elements to its left equals the sum of all elements to its right. Prefix sum or not in mind.
Given an array of integers, let us go through the signals first. So signals are range sum queries, subarray sum equals multiple queries or same array, running total or cumulative, 2D grid sum queries. Think range sum queries. Given an array of integers, find the index of the element where the sum of all elements to its left equals to the sum of all elements to its right. Prefix sum because range sum queries from left to right.
Correct pattern, but I want you to be more precise about the signal. It's not exactly a range query with LNR given to us. What's actually being computed at each index? For every index I, you need sum of everything to its left and sum of everything to its right. What does sum from index 0 to I minus 1 sound like to you?
Like sum of everything from index 0 to I minus 1 is nothing but prefix of r minus prefix of n minus 1, where r equal to I minus 1 here n equals 0. This is responsive.
Exactly right. And there's an even simpler way to say it. The signal here is running cumulative sum. Whenever problem needs the sum of everything up to a certain point, that's a prefix sum value directly.
I already gives you a sum of everything from index 0 to I.
Given the Inclusion matrix, answer multiple queries each asking for the sum of elements inside a rectangle. Prefix sum or not and why.
Prefix sum as per the signal. Prefix sum as per the signal to declare some queries.
Correct. This is called 2D prefix sum. The same idea extends from arrays to matrices. We'll cover it in the variation space. Next one. Given an array of integers, find the number of subarrays where the count of even numbers is greater than the count odd numbers. No sum mentioned, no key mentioned. Prefix sum or not.
Given an array of integers, find the number of subarrays where the number of even numbers is greater than the number of odd numbers. So if it is an even number, can you substitution take your track? Think about a 0 to -1 transformation can be used study. Given an array of integers and the number of subarrays where the number of even numbers is greater than the number of odd numbers. Number of even numbers and the number of odd numbers. Even numbers are divided by 2, odd numbers are not divided by 2. So if we add 1 to each of the margin, if it is 2 it will become 3. If it is 4 it will become 5. If it is 5 it will become 6. Think about the 0 to -1 transformation can be used earlier. That you will replacing on the 0 with -1, using sum equals this. In case of odd and even numbers, if there is an array with 6 elements, 1, 2, 3 code by 6. For sure, 1 is odd, 3 is odd, and 5 is odd. So 1 plus 3 is 4, 4 plus 5 is 9. And then we have 2, 4, 6, that is 12. Not quite getting it. The trick has to be some of the other relationship between even and odd numbers.
Good instinct. Here's the hint: what if you replaced every even number with +1 and every odd number with -1?
Okay, I was thinking about replacing only the even numbers.
After replacing evens with 1 and odds with -1, count of evens greater than count of odds means what in terms of the sum of this transformed array?
No, count of evens greater than count of odds means what in terms of the sum of this transformed array. In this case, count of evens is 3, right? 2 plus 4, 6, 6, 2, 4, 6, and odd is 1 and 3. So what we have done, we have converted even number to +1 and odd to -1. Count of evens greater than count of odds means what in terms of the sum of this transformed array. In terms of the sum of this transformed array, okay, if it's 1, then evens are greater, and if it's -1, then odds are greater, and if it's below, both are equal.
Very close, but think in terms of the subarray sum, not individual elements. If the sum of the subarray is greater than 0, what does that tell you about evens versus odds in that subarray?
Let us consider this 2, 3, 4. So in case of 2, 3, 4, becomes 1, -1 and 1. Here 1 -1 becomes, okay, Sagan and some being prefix upon, which is 1 minus and minus 2, which is again 1, 0. Okay. In case of Subarray sum, when sum equal to 0, evens are greater than 2 or 3, 4, 1. In case of 3, 4, 1, -1 Medicine consistency limits 0 right? Prefix of R is -1 minus prefix of L minus E. Later else its sum says less than 0, then boards are good.
Almost, but you flipped the first one. Remember, evens are +1 and odds are -1. So its sum is greater than 0, which is more evens or odds.
Could you repeat? Repeat last statement.
Remember, evens are mapped to +1 and odds are mapped to -1. So if the sum of a subarray is greater than 0, which count is more evens or odds?
Even is +1, odd is -1. So if a sum array has more evens, okay, then odds, the positive outweigh the negative. What does the sum look like? 4 evens, sum greater than sum.
Exactly. More evens means sum greater than 0. So the problem becomes find the number of subarrays with sum greater than 0. That's a prefix sum problem.
Okay, the transformation pattern is also.
This is the same trick as the zeros and ones problem, just a different disguise. Whenever you see two competing counts in a subarray, think +1 and -1 transformation / then prefix sum. One more recognition problem, the hardest one. Ready?
The transformation pattern is always the same. Identify the two competing things here, evens versus odds. Map one to +1 and the other to -1. The condition becomes a sum condition. Greater than 0 equals 0, etc. Now apply prefix sum. This is the same trick as the zeros and ones problem, just a different disguise. Ready for the hard problem? Yes.
Given an array of integers, find the number of subarrays whose sum is divisible by k prefix sum or not, and what would you store in the hash map this time?
Given an array of integers, find the number of subarrays whose sum is divisible by k. No transformation needed here, but the hash map trick changes slightly. Prefix sum or not and what you store in the hash map. It is prefix sum. I pick sum. Think about what divisible by k means mathematically. Divisible by k means if sum is 10 and k is 2, divisible by k means the remainder is c. If it's sum divisible by k means the remainder is here.
Good start. Divisible by k means remainder is 0, correct? Now here's the key question. If prefix of r minus prefix of l minus 1 is divisible by k, what does that tell you about the remainders of prefix of r and prefix of l minus 1 individually?
If some r minus prefix of n minus v is divisible by k, what must we do about prefix of r mod k and prefix of n minus v mod k? If prefix of r minus prefix of l minus y is divisible by k, What must be true about prefix of R mod k? Prefix of R mod k. If prefix of R minus prefix of n minus 1 is divisible by k, what must be true about prefix of R mod k?
Look at the table. Notice indices 0 and 3 both have remainder 0, and indices 2 and 4 both have remainder 2. What do you think it means when two indices share the same remainder?
Prefix of 3 minus prefix of 0. Prefix of 3 is 9. 50% 0, 0. So 9 minus 3 is 6. Yes. The x of 3 minus prefix of 0, it is divisible by 3. Can you write that 3 is the sub R mod k? So R is line. Wing mod k. So take it leave it by prefix on in minus y, which is 3. 3 over 3. So gain 0. That's it is divisible by 3.
Exactly. Prefix of 3 minus prefix of 0 equals 9 minus 3 equals 6, which is divisible by 3, and both had the same remainder 0.
Now check it.
Conclusion is, if two prefix sums have the same remainder when divided by k, the subarray between them is divisible by k. So what do you store in the HashMap?
Okay, so the conclusion is if two prefix sums have the same remainder when divided by k, the sum array between them is divisible by k. If two prefix sums have the same remainder and divided by k, the sum array between them is divisible by k. So what do we store in the hash map?
Close, but be more specific. You're storing something you compute at each index. Based on what we just traced, what exactly do you store as the key in the HashMap?
X of on marquee. These two key in the hash map.
Exactly. You store prefix sum mod k as the key and the count of how many times that remainder has been seen as the value. Whenever you see the same remainder again, all those previous indices form valid subarrays with the current index. You've recognized 5 prefix sum problems, including disguised ones and a modulo twist. That's strong pattern recognition. Ready to move to phase 4, pitfalls and gotchas. Phase 4, pitfalls and gotchas. These are the mistakes that cost people marks in interviews even when they know the pattern. Let's go through them one by one. Here's a buggy formula. Range sum equals prefix of R minus prefix of L. What's wrong with this?
The correct formula should have prefix of L minus 1.
Exactly, prefix of R minus prefix of L excludes the element at index L itself. You're subtracting one position too far. The correct formula is prefix of R minus prefix of L minus 1. In the subarray sum equals k problem, what happens if you forget to initialize the hash map with 0 map to 1?
In this case, the handling of L equal to 0 will cause problems.
Exactly. Without that initialization, any subarray starting from index 0 will be missed entirely. It's a silent bug. Your code runs fine but gives wrong answers on certain inputs. Find the maximum sum subarray. Someone suggests using prefix sum. Is that the right pattern here, and why or why not?
Someone suggests using prefix of is that the right pattern here, and why or why not? Negative numbers. This one catches a lot of people. Consider this problem. Find the maximum sum subarray. Someone suggests using prefix sum. Is that the right pattern here? And that is prefix sum is the right pattern here, as the signal being maximum sum followed by subarray.
I'll push back on that. Prefix sum can compute any subarray sum in O of 1, but can it tell you which subarray has the maximum sum? How would you find the maximum using prefix sums?
Prefix sum can compute any subarray sum in the O of 1, but can it tell you which subarray has the maximum sum? Yes, we can make use of HashMap to store the maximum sum for a given subarray.
Think about how many subarrays exist in an array of size n. How many pairs O, L, and R are there, and what would be the total time complexity of checking all of them?
Think about how many subarrays exist in an array of size n. Many subarrays. Subarrays in minus 1. How many pairs of Helena are there? Many pairs. First pair, second pair, third. Most nine.
There are O of n squared pairs or L and R, so checking all subarrays even with prefix sum would still be O of n squared. That's no better than brute force. This is the critical pitfall. Prefix sum tells you the sum of a given range efficiently, but it cannot search for the optimal range by itself. For maximum sum Subarray, use Kadane's algorithm. Some people build the prefix sum array in place by modifying the original array. What's the danger of doing that?
What's the danger of doing that? Do we at any place use the original subarray, use the original array for any reference? For pix of our mouse, pix of 10. What's the danger of doing that? Let us go through our previous example. So here we have our original array. This is a prefix array. Formula becomes, using prefix array, we can calculate the prefix sum efficiently. But if we do that directly here, what problem will we face? That is equal to tau in equal to prefix of r plus 1. Prefix of r plus 1 z on just great. Minus prefix of c1. Yeah, the original array is still 1, so the index 0 is true. And index minus me, index 2 is 1. That sounds like not right. So your formula application button next recheck the prefix array with the Sentinel. Okay. So 4 is in F1 9. So fine. The Sentinel array, look at the trigger prefix array is this. The formula was spot on. Ready to move. But if this is the original array, this is the prefix array. If let us say there is no original array, are we using original array anywhere? Prefix of r plus 1. Modifying the, some people build the prefix sum array in place by modifying the original array. What's the danger of doing that? Okay, see, we are given an array and we want to calculate its prefix. If we do it in place, like I say, the array is C3, 1, 4, 5. If we calculate this prefix, then this will become 3 followed by 3+1, 4, followed by plus 38, followed by 30. I don't think there is any calm of modifying the original array in place. What if after building the prefix sum?
Good reasoning, but what if after building the prefix sum, the problem also needs you to access the original values of the array? If you modified in place, what happened to those original values?
The original values we get overwritten, and this because the program to not terminate. Correct.
Exactly. Once you overwrite the original array, those values are gone forever. Always build the prefix sum as a separate array. Never modify the input unless the problem explicitly allows it.
Integer okay.
If your array has 1 lakh elements each with value 10 to the power 9, what happens to your prefix sum values? Think about the maximum possible prefix sum.
Okay, this one is language dependent but critical in interviews. If your array has n equal to 1 lakh elements, each with value 10 raised to 9, what happens to your prefix sum values? Each with value 10 raised to 9. So the 1 lakh element sum would be A work plus K equals to 10 raised to 9 plus K root of 10 raised to 12. See, this way being the element of 10 raised to 9. So, as per the language, need to identify what can store 10 raised to 9 successfully and then use net data type such that it doesn't overflow.
Exactly. The maximum prefix sum could be 10 to the power 14, which completely overflows a 32-bit integer. In Java or C++, always use long. In Python, integers are arbitrary precisions, so you're safe. 5 pitfalls off by 1 missing HashMap initialization, using prefix sum to search for optimal range, modifying the original array and integer overflow. These are the ones that silently break corrected in code. Ready to move to phase 5, pattern variations?
Any other pitfalls apart from this?
Here's two more important ones that come up specifically in interviews.
Okay.
In the subarray sum divisible by k problem, what is -1 mod 3 in Java or C++? Take a guess.
In the subarray sum divisible by k problem, what happens if a prefix sum is negative? For example, prefix sum equal to -1 k equal to 3. What is 1 mod 3? 0 minus 1.
Exactly, and that's the problem. In Java and C++, -y mod 3 gets -1, not +2. But mathematically, -1 and +2 are the same remainder when dividing by 3. The fix is remainder equals prefix mod k plus k. On mod k, this always gives a non-negative remainder regardless of the language. In Python, you don't need this. Python's modulo always returns non-negative. In the subarray sum equals k problem, should you add the current prefix sum to the HashMap before or after checking if prefix minus k exists in a... Think carefully, order matters here.
Updating a hash map at the wrong time, the subarray sum equals k problem. Should you add the current prefix sum to the hash map before or after checking if prefix minus k exists in it? Prefix minus k exists before could it make any difference in the subarray sum equals k problem? Should we add the current prefix sum to the hash map before or after checking? After checking.
Exactly right. If you add the current prefix sum to the HashMap before checking, you might count the current index as a valid previous index, creating a subarray or zero length. Always check first, then update the HashMap. 7 pitfalls total. The last two negative remainders and wrong HashMap update order are the ones most people only discover when their solution fails on edge cases. Now shall we move to phase 5, pattern variation.
Okay, let me ask. Are there any more pitfalls?
Good instinct to push. Yes to know that are subtle but important. Can you use prefix sum plus HashMap to find subarrays with sum equals k when the array contains negative numbers?
Think about this. Can you use prefix sum plus hash map to find the number of subarrays with sum equals k on the yes?
Correct prefix sum plus HashMap works fine with negative numbers, but sliding window breaks with negative numbers because shrinking the window doesn't guarantee the sum decreases. That's the key distinction. The pitfall is reaching for sliding window when the array has negatives. With negatives, always use prefix sum plus HashMap. Sliding window will give wrong answers. Prefix sum always requires old and extra space. What's the pitfall here? When might an interviewer push back on your solution because of this?
Trust space for the bit of salary. What's the pitfall here in an interview? Space complexity blind spot. Prefix sum always requires to go off an extra space for the prefix array. What's the pitfall there in an interview? Try to use extra space could be the reason the interviewer may push back. However, you can tackle that by answering it is the go of n once and then for on efficient queries it is the go of 4.
Exactly right. The trade-off is O of n space for O of one query time. That's a perfectly justified trade-off and any interviewer will accept that answer. What if the interviewer says the array is being updated frequently between queries, elements are changing? Does prefix sum still work efficiently?
What in the interviewer says the array has been updated equally to 4 queries. Elements are changing. Does prefix sum still work? No. If the environments are changing, then prefix so over. Because in one calculating the prefix sum after each element change.
Exactly. Every update forces you to rebuild part of the prefix array, costing O of intra-update. That's when you need a more advanced data structure, a Fenwick tree, also called a binary index tree, or a segment tree. Both handle updates and queries in old log n.
So the complete picture is static array mutable queries.
9 pitfalls total. The last one is critical for senior interviews. If the array is mutable, prefix sum alone is not enough. You need a Fenwick tree or segment tree. Ready for phase 5, variations?
Yes, let us begin with phase 5 variations.
There are 4 main variations of prefix sum, all built on the same core idea just applied differently. Let's go through them one by one. Variation 2 is prefix sum plus HashMap. Instead of answering a given range query, you're searching for subarrays satisfying a condition. The key insight is transforming the equation to look up a complement in the HashMap. In the longest subarray version of this problem, what should the HashMap store instead or count?
Okay, so the first variation is 1D prefix sum. Use when range sum queries on a one-dimensional array. Variation 2 prefix sum plus HashMap. Instead of just answering what is the sum from L to R, you are now searching find subarrays with a specific sum, count them or find the longest one. You have already seen this with the subarray sum equals k problem. The core idea prefix of R minus prefix of L minus 1 is equal to k becomes prefix of L minus 1 is equal to prefix of R minus k. Look up the complement in the hash map. In variation 2, the hash map stores prefix sum equal to count. But in the longest subarray version, what should it store instead? Okay, the hash map stores prefix sum count. Like fix sum count, but in the longest subarray version, what should it store instead? In the longest subarray version, what should it store instead? Shouldn't it be the count itself?
If you want the longest subarray, you need to maximize R minus L to compute R minus L. You already know R, it's the current index. What do you need from the hash map to compute the length?
Think about it differently. If you want the longest subarray, You need to maximize R minus L. What information do you need to compute that? What information do you need to compute that? The value for R and L. The current index.
You already have R, it's the current index. So what specifically do you need the hash map to give you in order to compute the length?
Okay. We need L from the hash map. Compute the length.
Exactly. So for longest subarray, the hash map stores prefixed sum mapped to its earliest index, not its count. That way length equals current index minus the stored index.
Okay.
Two subflavors counting stores prefixed sum to count longest stores prefixed sum to first index. Never update the index once stored because you want the earliest L to maximize length. In 2D prefix sum, prefix of ij stores the sum of all elements in the rectangle from the top left corner to position ij. The query formula subtracts two overlapping regions and adds back what was subtracted twice. Does that formula make visual sense to you?
In two-dimensional, prefix of ij is equal to sum of all elements in the rectangle from 0, 0 to I, j. To query any rectangle from R1 C1 to R2 C2, prefix of R2 C2 minus prefix of R1 minus 1 into C2 minus prefix of R2 C1 minus 1 plus prefix of R1 minus 1 C1 minus 1. What is R2 C2? R1 C1 R2 C2 R1 C1 prefix of R2 C2. Give an example. For 2D prefix, so
Prefix of 1 1 equals 12 because it's the sum of the top left 2 by 2 rectangle. 1 plus 2 plus 4 plus 5 equals 12. Each cell stores the sum of everything above and to the left of it, including itself. (45 minus 6 minus 12 plus 1 equals 28). And manually, 5 plus 6 plus 8 plus 9 equals 28. The formula works. Can you see why we add back prefix of 0, 0 at the end?
how do we get sum of 1 equal to 2? This is the original matrix. R1 C1 0 to ij. So it is 0 0 0 1 0 3, then 1 0 1 1 1 2 2 0 2 1 2 2. So click x of 1 1 is equal to 12. It's the sum of the top left 2 by 2 rectangle. It's 1 3 5 12. It's the sum of the top left 2 by 2 rectangle. 1 3 5 2 1 plus 2 plus 4 plus 5. Where is 2? Okay, this is the original matrix. 1 2 4 5. So top left you get 1 plus 2 plus 4 plus 5, which equals 12. What is the sum of rectangle from 1, 1 to 2, 2? That's the bottom right row to matrix 2 at 5, 6, 8, 9. So prefix of 2, 2, 0, this prefix of 2, 2, minus prefix of 0, 2, minus prefix of 2, 0. And if you finally have 5 plus 6 plus 8 plus 9, 5 plus 6 plus 8 plus 9 is equal to 28. Right? Sum of common elements in the rectangle from 0, 0 to ij. How to relate prefix of 1, 1, 2, 2, 2. Let's say sum of the top left 2 by 2 rectangle. 1 plus 2 plus 4 plus 5, which is 12. So we have 12 over there. Then what is the sum of the rectangle from 1, 1 to 2, 2? From 1, 1, 5, 6, 8, 9. See, that becomes prefix of 2 comma 2. Prefix of 2 comma 2 minus prefix of 0 comma 2 minus prefix of 2 comma 0 minus prefix of 0 comma 0. How is this formula would generate?
Great question. Let me build the intuition visually. Think of it like overlapping rectangles. You start with the full rectangle from 0, 0 to 200 hours C2. Then subtract the region above your target and subtract the region to the left. But those two subtractions overlap in the top left corner, so you subtracted that corner twice. You add it back once to compensate. This is the inclusion-exclusion principle. Full rectangle minus above minus left plus the overlap you subtracted twice. Does that derivation make sense now?
Inside says, imagine you want the sum of the shaded region, rectangle from R1 C1. This is R1 C1 to R2 C2. Right? So these rows are unwanted. And also these columns left are unwanted. And then prefix of R2 C2, which is this, gives you the entire rectangle. Okay, so this prefix gives you the entire rectangle from 0, 0 to R2 C2. That's the whole thing, including unwanted parts. We need to subtract two unwanted regions. Which is this one 0, 1, 0, 2, 0, 0, 1, 0 and 2, 0. XX subtracted once above. 0, 0 subtracted twice overlap. Then 0, 0 subtracted once left. So these 0, 0 here subtracted twice overlap. And this 0, 0 subtracted once. So you add back the overlap once. Plus prefix of R1 minus 1. Then C1 minus 1. This is called the inclusion-exclusion principle, a fundamental idea in combinatorics. The formula is full minus above minus left plus overlap added back. Thus that derivation makes sense now. Yes. Load completely.
That's fair. Let me make it more concrete using our actual numbers. We start with 45, the entire matrix. We subtract 6, which is the row above our target. We subtract 12, which is the column to the left of our target. But the top left cell, value 1, was inside both regions we subtracted, so we subtracted it twice. We add it back once. 45 minus 6 minus 12 plus 1 equals 28. Think of it like a Venn diagram. When you subtract two overlapping regions, the overlap gets removed twice, so you add it back once. Is it clearer now?
Yes.
Great. 2 more variations to go. Difference array is the reverse of prefix sum. Instead of answering queries, you're applying range updates. Brute force costs of in per update. Can you guess what the difference array trick costs per update?
This is the reverse of prefix sum. Instead of answering range sum queries, we're applying range updates efficiently. The problem it solves: given an array, perform Q operations. Each operation adds a value V to all elements from index array to R. After all operations, return the final array. The brute force costs big of n per update. Big of n into Q property. Can you guess what the difference array trick costs per update? Yes, what the difference array trick cost per update? Echo of 1.
Exactly O of 1 per update. Here's the idea. For each range update, you add V at index L and subtract V at index R plus 1. After all updates, take the prefix sum of the difference array to get the final result. Why do you think subtracting at R plus 1 works?
Okay, operation to add 2 to indices 0 to 2. Let's trace through an example. Array size 5, all zeros initially. Operation 1, add 3 indices. Add 3 to indices 1 to 3. 3 to indices 1 to 3. Kill operation 2 and 2 to indices 0 to 2. Now take prefix sum of def. After all updates are done, you take the prefix sum of the difference array to in the final array. Take those sum of this. You maintain a difference array of the same size initialized to all zeros. To add value V to all elements from index L to R, diff of L plus equal to V, diff of R plus 1 minus equal to V. That's it, just 2 operations in before of R. After all updates are done, you take the prefix sum of the difference array to get the final array. Okay. But hereby there are only 2 operations.
Great question. Think about what the prefix sum of the difference array does at each index. Adding V at L makes the prefix sum carry V forward from index L onwards. Subtracting V at R plus 1 cancels it out, so it stops flowing after index R. The prefix sum does all the heavy lifting. You only need 2 operations per update. Think of it like a tap. Diff at L turns it on, diff at R plus 1 turns it off. The prefix sum reads how much is flowing at each point. Does that click? Perfect. Now the last variation. Prefix sum works on any property you can accumulate, not just numbers. On strings, you can precompute character counts. On Boolean arrays, you can precompute counts of true values. The pattern is the same, just change what you're accumulating. Five variations: 1D HashMap combo, 2D difference array, and strings, all built on the same core idea of precomputing cumulative information. Ready to move to phase 6, mini exercises.
Yes, let us begin with some mini exercises.
Exercises, let's go. I'll give them one at a time. Ready for the first one? Give an array 2, -1, 3, 4, -2. Build the prefix sum array with a Sentinel 0. What does it look like?
Okay. Let me open VS Code. So we have to build prefix sum array with Sentinel 0. So this is our original array, and the prefix array will be prefix sum array with Sentinel 0 will be 0, then 2 plus 0 is 2, then -1 plus 2 is 1, then 3 minus 1, oh no, 2 minus 1 is 1, 1 plus 3 is 4, first is 0, then 2 plus 0 is 2, then -1 plus 2 is 1, then we have 3, 3 plus 1 is 4, then we have 4, 4 plus 4 is 8, then we have -2 plus 8 is 6. Sure is the output.
Perfect, exactly right. Sentinel 0 / then dui, ek chariot, choyo. The negative numbers didn't trip you up at all.
Find the bug.
There is one bug in this code. Look carefully at the HashMap initialization and find it.
Okay. The hash map should have been initialized with C equals 0 marking a sentinel behavior.
Exactly right. Without that initialization, Subarrays starting from index 0 with sum equal to k get missed entirely. That's pitfall number 2 from our list. Arrays 1, 2, 3 and k equals 3. Using the corrected code, trace through the loop state by state they'll need for count. Show your work at each step.
Okay. Show your work prefix value, what you look up, what is in scene at each step. This is the array. Let me split right, and then scroll out, copy the code. Here we have the code. This is on array case 3. So initially for num in array. Okay, prefix plus equal to num. When num is equal to 1, then prefix is initially 0. For 0 plus num is 1, it becomes 1. After that, if prefix minus k is seen, what is prefix minus k? Prefix is 0 and k is 3. Right, prefix is 1. 1 minus 3 minus 2 in scene, no. For this, if will be evaluated to false, this line will not execute. Scene of prefix is equal to scene dot get prefix 0 plus 1. If will not execute, then scene of prefix which is 1 is equal to scene dot get prefix comma scene plus 1. Scene dot get prefix. Okay. What is this get? Since I'm not aware of Python, just explain this in one line. As my background is not from Python. Oh.
It means look up prefix in the hash map, return its value if it exists, otherwise return 0. Then add 1 to increment the count. In Java, it's get a default of prefix 0 plus 1.
Okay, got it. So prefix is 1. It doesn't exist, so it will return 0. 0 plus 1 is 1. So scene of 1 will be set to 1. That is scene is now first for 0 it is 1, and for 1 it is 1. Then when num is equal to 2, that time prefix is equal to prefix plus num. Prefix is now prefix from the earlier iteration is set to I. So 1 plus num is 2. Prefix was now 3. So if prefix minus k, prefix is 3. 3 minus k is also 3. So 0 is seen if we'll execute. And then count plus equal to count in equal to count plus c of prefix, which is 3 minus 3, 0. 0, 0. So that becomes count is initially 0 plus c of 0 is 1. So it becomes 1. Count is now 1. Then we have scene of prefix, which is 3, is equal to scene dot get prefix, which is 3 comma 0 plus 1. In this case also, the scene does not have the key 3, hence it will return 0 by default, and the answer will be 3. And after this, scene will now become scene is equal to 0 will be set to 1, 1 will be set to 1, and 3 will be set to 1. After that, when num equals 3, that time prefix is equal to prefix plus now. From the previous iteration, prefix is 3, now num is 3. So prefix becomes 6. If prefix minus k, that is 6 minus 3. In scene, yes, if we'll execute, And this will set count is equal to count plus scene prefix is 6 minus 3. It becomes 3. And this will be count if from the previous iteration count is set to 1. So this becomes 1 plus scene of 3 is 1. Count becomes 2. After that scene of prefix is set to 6. Scene prefix is equal to scene dot get prefix 6 cover 0 plus 1. So this will be 1. Then scene will be set to, for 0 it is 1, for 1 it is 1, for 3 it is 1, 6 it is 1. And at last the return count will be the return count equals to count value will be returned as 2. Has to.
Excellent trace, but there's one mistake. When noun equals 3, prefix equals 6, and you check if prefix minus k exists in scene, that's 6 minus 3 equals 3. Does 3 exist in scene at that point?
Okay, x minus k. Yes.
What's subarray 1, 2, 3 ends at index 2 and has sum equal to 3? Think about it. Does such a subarray actually exist?
Excellent trace, but there's one mistake. Let me point you to it. You wrote count equal to count plus scene of 3. C of 3. Yes. But what subarray does that actually represent? Is there really a subarray of 1, 2, 3 is sum equal to 3 ending at index 2? Yes. Yes. The subarray 1, 2.
Exactly, 1 and 2 sums to 3, and 3 alone also sums to 3. So count equals 2 is correct. Your trace was right all along. I steered you into doubting yourself. Well done for holding your ground. Given an array of size and with Q range sum queries, what is the time and space complexity of the prefix sum solution, and how does it compare to brute force?
Given an array of size and with Q range sum queries, so time complexity will be complexity go of L times Q, where Q is the number of range sum queries, and ultimately L complexity becomes big O of N space complexity. Given an array of size n with Q range sum queries, what is the time and space complexity of the prefix sum solution, and how does it compare to brute force? Space complexity should be need only one cumulative running sum. Space complexity of 1 as we when it used only one running sum. Only Comparing that with brute force, it becomes 50 go of n square.
You've mixed up brute force and prefix sum complexities. Let me ask you separately, what is the time complexity of the prefix sum solution, only including both building and querying?
Building the prefix array will be go of query. The query will be either of one.
Exactly. Building is O of n, each query is O of 1, and there are q queries. So what is the total time complexity combining all three?
Okay.
Close, but you're forgetting q building costs O of n once and q queries cost O of 1 each, so total is O of n plus q. When q is very large, that q term matters. Now for space you said O of 1, but we are building a separate prefix array of size n. What is the actual space complexity?
I assume they will not be building a separate prefix sum array. Thus I said we go of 1, but that is not the case. Hence, for the above, the space complexity becomes below of n.
Exactly. Prefix sum trades O of n space to get O of n plus q time. Brute force uses O of 1 space but costs O of n times q time. That's the classic space-time trade-off. Three problems. Which prefix sum variation does each one use? First, add 5 to all elements from index 2 to 7, repeated for q operations. Second, find longest subarray with sum 0. Third, sum of elements in a rectangle in a matrix.
So first will be add 5 to all elements from index 2 to 7. Repeat for q such operations. Return final array. So that would be pattern identification. So add 5 to all elements from index. So first one is range sum queries. Range sum queries. Find longest subarray with sum equal to 0. So that this is subarray with sum equal to k. In this case, k is equal to 0. And at last we have 2D grid sum queries.
You identified the signals correctly, but I asked for the variation names. Let me map them for you.
Okay.
Problem 1 is the key correction. Adding a value to a range is a range update. That's the difference array variation. Range sum queries answer what the sum is. Difference array applies changes to a range. Those are opposite directions. Ready for the final two exercises.
Yes.
Someone is finding the longest subarray with sum k. There is one bug in this code. Find it. Think carefully about what the hash map should store and when it should be updated.
The hash map must store initially instead of this must have can prefix plus equal to noun. Someone is trying to find the longest subarray with sum equal to k. Yes, their code. Longest sum has seen prefix max length. For I, num in enumerate array, prefix plus equal to num if prefix minus k is in C. Max length is equal to max of max length, I minus C in prefix minus k. Scene of prefix.
Good instinct, but this is the longest subarray variation, not the count variation. The hash map stores indices here, not counts. So what should the Sentinel initialization actually be? The Sentinel says prefix sum or 0 was seen at index what before the array even starts. What index is that?
That's -1.
Exactly. The correct initialization is seen equals 0 mapped to -1. With 0 mapped to 0, a subarray starting from index 0 would compute length as I minus 0, missing one element. With -1, it computes I minus -1 equals I plus 1, the correct length. Also, the code always overrides seen with the current index. But for longest subarray, should you overwrite an existing entry or keep the first one?
Also notice the other key difference in this variation. Seeing prefix of I only updates if the prefix sum is not already in C. But the code above always overrides. Can we spot why? Why that's also a bug? Always overrides. Someone is trying to find the longest sum and with sum equal to k. Yes, there go. Seeing prefix of I. Also notice the other key difference. Only updates if the prefix num is not already in C. But the code above always overrides, right? C. It's not always C, but the code above always here is to export the cases. So it always overrides. Z.
Actually, the opposite for longest subarray, you are to keep the earliest index, not update to the latest. The earlier the L, the longer the subarray. So you should only store a prefix sum if it's not already in scene. 2 bugs total ROM Sentinel index and overwriting instead or keeping the earliest. These 2 bugs together would give wrong answers on many inputs silently. Ready for the last exercise?
If prefix not in CL, see a prefix below I. Key. But can always already seen prefix should only store if not already present. Yes.
Array of size 5, all zeros. Operation 1, add 4 two indices 0 to 2. Operation 2, add 2 indices 1 to 4. Trace through the difference array and give me the final result array.
Okay, first is this is our array. First, apply these two operations. Add 4 to indices 0 to 2. After first operation, the array becomes add 4 to indices 0 to 2. 4, 4, 0, 4. The last two remains 0, 0. Trace through the difference array step by step and give me the final result array. Add 2 to indices 1 to 4. The CK operation, the array becomes add 2 to indices 1 to 4. The 6, 6. About to see. Spin 1 with 3. Okay.
Correct final answer, but you solved it using brute force, not the difference array technique. Let me ask you to redo it using the diff array. Build the diff array first, apply both operations as 2-point updates, then take the prefix sum.
Remember for
Start with diff of size 6, all zeros. Apply operation 1 as 2-point update, then operation 2 as 2-point update. Then take the prefix sum of diff to get the final array.
So we have to solve it using the difference subarray method. So initially we are given the difference subarray to put this. This is our formula. Diff of L. Then initially the first operation is add 4 to indices 0 to. Operation 1 is add 4 to indices 0 to 2. So here L is equal to zeros and R is equal to 2. We have to apply this to indices 0 to 2. So diff of 0 equals diff of 0 plus V is equal to 4 plus 4. So this becomes diff of 0 is 0, 0 plus 4 gets 4. Then diff of R plus 1, diff of R plus mod. R is 2 plus 1 equals diff 2 plus 1 minus v. So diff of 3 becomes diff of 3 minus v, which is 4, and diff of 3 is 0, 1, 2, 3. It is 0 minus 4. So the answer is minus 4. So after the first operation, the diff array becomes, let me copy this. First, the 0th element is 4 and the third element 0, 1, 2, 3. This is minus 4. Now we will be incrementing L, which will go to 1. R will stay at 2. So here diff of 1 plus equal to b. So diff of 1 becomes 4, and then diff of say come plus 1. So come plus 1, 3. 3 will remain the same. No, 3 is no minus 4. Now diff of 3 equals diff of 3 is minus 4 minus 4. So it becomes minus 8. Now the array will become as 8. Diff of 1 will be 4. After this, L will be 2 and R is also 2. So diff 2 will become 4 and diff of 3 will become minus 12. So the diff array will become 4 and this will be minus 12. Let me verify this. Verify if the diff array after first operation is correct. You are doing brute force again, applying the operation.
You're still doing it element by element. The difference array needs exactly 2 operations for the entire range, just diff at L plus 4 and diff at L plus 1 minus 4. That's it. The prefix sum does the rest. After operation 1, diff is 4, 0, 0, negative 4, 0, 0. Now apply operation 2, add 2 indices 1 to 4. Just 2 touches? What does diff look like after operation 2?
Operation 2 is add 2 indices 1 to 4. So that will be diff of n was equal to be diff plus 1 minus equal to v is equal to 2, L is equal to 1 and R is equal to 4. So diff of L, which is 1, it becomes 0 plus 2, that is 2. Then diff with power plus 1, which is 5. So that becomes 0 plus 2, again 2. So the final diff array is equal to this is 2, 0, 2, 3, 4, 5.
Almost, but check diff at or plus 1. The formula says subtract v there, not add it. What should diff at index 5 be? Perfect. Now take the prefix sum of diff equals 4, 2, 0, negative 4, 0, negative 2. What is the final result array?
Prefix sum is 4. This 4 is 6. This is also plus by 6. 6. Then minus 4 plus 6 minus 2. And there is 0 minus 2, so again minus 2. Then minus 2 minus 2 minus 4.
At index 3, it's 6 plus negative 4 equals 2, not negative 2. The final result array is 4, 6, 6, 2, 2, which matches your brute force answer exactly. The difference array works.
Oh, got it.
7 exercises done. Strong performance overall. Ready to move to phase 7, real problem mapping.
Yes.
I've mapped the key lead code problems to each variation on screen. Take a moment to read through them.
1D prefix sum, range sum query, immutable.
When would you use sliding window instead of prefix sum for a subarray sum problem? What's the deciding factor?
Onto prefix sum, range sum query, running sum of 1D array, prefix sum plus HashMap, sum array sum equals k, continuous sum array sum divisible by k, number of subarrays with bounded maximum, prefix sum plus HashMap, longest maximum size subarray sum equals k, contiguous array equals zeros and ones, longest subarray with equal number of zeros and ones. So the most important part of this piece, prefix sum gets confused with two other patterns. Let me ask you, when would you use sliding window instead of prefix sum for a given subarray sum problem? Okay, for a given subarray sum problem, all the elements are positive, then go with sliding window.
Exactly. All positive elements sliding window. Mixed or negative elements prefix sum plus HashMap. That one rule will save you from a very common interview mistake. When would you use a HashMap alone without prefix sum versus prefix sum plus HashMap together? What's the difference in what they solve?
When would you use a HashMap alone without prefix sum versus prefix sum plus HashMap together? When would you use a HashMap alone without prefix sum versus prefix sum plus HashMap?
Prefix sum plus HashMap in case of elements being negative, mixed positive, or to find subarray sum equals k. When would you use a HashMap alone? HashMap alone to find longest occurrence for stream.
Good instinct, but let me sharpen the distinction more precisely. The key signal is individual elements or contiguous ranges. Individual elements need only HashMap. Contiguous ranges need prefix sum to compress the range into a single value, then HashMap to search. That's the real distinction. Ready to move to phase 8, knowledge verification. This is where I test everything you've learned today.
Yes.
Knowledge verification. I'll ask one question at a time. Don't rush, think carefully before answering. In your own words, explain the code trade-off of prefix sum in one sentence. What do you give up and what do you gain?
We give up calculating prefix sum in gecko and time, and we gain the benefit of querying in table of 110.
You are not giving up the calculation, you're spending O(n) time and O(n) space up front. What do you give up in terms of space and what do you gain in terms of query time?
Good, but you said give up calculating, okay, which is a bit confusing. You are not giving up anything by calculating it, you are spending O and time. What exactly are you?
You see, we are maintaining another array that moves a prefix sum, whereas it gives us the benefit of querying in equal of 1.
Perfect. You spend O(n) space to build the prefix array and gain O(1) query time. That's the trade-off in one sentence. What are the two subflavors of prefix sum plus HashMap, and what does the HashMap store differently in each one?
First, if we need to keep the count, the hash map starts with 0, 0, whereas if we need to find the subarray, in that case the hash map starts with 0 minus 1.
You got the concept right, but the first initialization is wrong. For the count flavor, the Sentinel means we've seen a prefix sum of 0. How many times have we seen it before we start? Exactly. Count flavor stores prefix sum to count initialized with 0 to 1. Longest flavor stores prefix sum to first index. initialized with 0 to -1. Those two initializations are critical to get right. Given an array of integers, find the number of subarrays whose sum is divisible by 6. Which variation, what do you store in the hash map, and how do you handle negative numbers?
Okay, walk me through exactly on your solve this. Which variation would you store? I think I'll have to look up for the variation part. Now the variation would be variation difference. Keep walking through exactly. Given an array of integers, find the number of subarrays. Find the number of some sub answer since variation is prefix plus hash map. What you store in the hash map? Since you have to find the subarray, so hash map will start from 0, variation in -1. Hash map starts with this of subarrays. Those you handle negative numbers. Get for negative numbers. We calculate with the remainder by this. Which is prefix of I mod k, this plus k, and this whole thing mod k.
Almost perfect, but one mistake. This problem asks to count subarrays, not find the longest. So what should the hash map initialization be? Exactly. Variation is prefix sum plus hashmap count flavor, initialized with 0 to 1 stored remainder as key and handle negatives with the double modulo formula. That's a complete correct answer. Given array 3, -3, 3 and k equals 3, how many subarrays have sum equal to 3? List all the valid subarrays.
Okay. Valid summaries include just 3, 3 comma -3, then -3 comma k, next 3.
Almost, but check the subarray 3, -3. What is its sum?
Is 0.
Exactly, 3 plus -3 is 0, not 3. Remove it. What about the full array 3, -3, 3? Is that a valid subarray with sum equal to 3?
So these are the two subarrays.
3 valid subarrays, 3 at index 0. the full array 3, negative 3, 3, and 3 at index 2. Count equals 3. Good reasoning. Given a large sorted array that never changes, answer 10 million range sum queries. What is your approach and what is the optimal time and space complexity?
Approach would be to use prefix sum, since the array is sorted and never changes. Q is large sorted array that never changes. Answer 10 million range sum queries. Approach would be to use prefix sum since the array is sorted and never changes. Optimal time and space complexity are space complexities big O of n and time complexities big O of n plus q.
You've got the right approach and the right complexities, but they're swapped. Which one is time and which one is space? Perfect. And one bonus point, the interviewer said the array is sorted. Does that change anything about your prefix sum approach? Exactly right. Sorted or unsorted makes no difference to prefix sum. It works on any static array regardless of order. The interviewer may have said sorted to distract you into thinking about binary search instead. Knowledge verification complete. Strong performance with only minor corrections. Ready for the final phase mastery assessment.
Ready for the final phase mastery assessment? Yes. Let's get started.
Your understanding score is 7.5 out of 10 and confidence score is 7 out of 10. Strong intuition and recognition skills are your biggest strength. HashMap initialization confusion is your biggest weakness. Nail that and you're at a 9.
Okay, understanding score 7.5 out of 10, confidence score 7 out of 10, biggest strength, excellent intuition and pattern recognition. You independently derived the core idea of prefix sum before being taught it, correctly identified all 5 recognition signals and distinguished between count versus longest hashmap flavors after minimal prompting. Biggest weakness, mixing up conventions under pressure. You confused 0, hashmap 0, 0, 0, 1 and 0 minus 1 initializations multiple times across the session. This is the kind of mistake that silently breaks correct looking code in interviews. Most important gotcha, hashmap initialization is everything. The Sentinel value differs by variation. Count 0 to 1, longest 0 to minus 1, modulo 0 to 1 with double modulo for negatives. Getting this wrong produces silent bugs. Your code runs but gives wrong answers on edge cases. What to study next? Implement all 3 hashmap flavors from scratch in code. Solve lead code 560, 525, 523 in that order. Then move to 2 pointers pattern. It pairs naturally with what you learned today about sliding window versus prefix sum distinctions. Great session today. Prefix sum is now in your toolkit, not just memorized but understood. Perfect.
You came in knowing nothing about prefix sum and left with a solid 7.5. The intuition was always there, we just gave it a name and a framework.
Perfect. So this is for my viewers. I have been learning prefix sum from the past 2 days, and this is the last topic which I recorded today. And it took me more than 2 to 3 hours to just brush up the fundamentals and create an intuition and come to a conclusion that finally I understand prefix sum. However, I'm going to solve the lead code problems which has been given by my AI tutor to verify whatever I have learned so far sticks with me. So if learning is hard, do the hard things, your life will be easy. Don't just skip it if it is hard. Press on it. If it is hard, it means no one is doing it. That means more for you. It was said by Chris Williamson. So quoting that and ending the prefix sum lecture, I hope you would have gained some insights into prefix sum. If yes, please do like, share and subscribe. Thank you.